So from exercise 8.1, this is the next question in continuation with the previous video. So I have given 15 cot A is equal to 8. Find sin A and sec A. So this 15 cot A, I can shift 15 to the other side. So I have cot A is equal to 8 by 15. Now if I draw this on a triangle, so what does cot A mean? The ratio cot is given by adjacent side by the opposite side. Adjacent and opposite side with respect to which angle? With respect to angle A. So let this angle be A. So adjacent side is 8x and the opposite side would be 15x. Now let this be B and C. So using Pythagoras theorem, I have AC square is equal to BC square plus AB square. So that is 15x the whole square. That's BC. BC is 15x, so BC whole square plus AB. AB is 8x the whole square. 15x the whole square is 225x square plus 64x square. Now 225 plus 64 is 289. So AC square is equal to 289. AC is equal to root of 289. So AC is root 289, which is 17. So AC is 17. I missed out an x here. So root of 289 x square. So this is 17x. Now I want sin A. Sin A is given as opposite side by the hypotenuse. Opposite side and hypotenuse with respect to angle A. So the side opposite to angle A is 15x and the hypotenuse is 17x. So this ratio sin A would be 15 by 17. Now sec A. Sec is reciprocal of cos. So sec is given by hypotenuse by the adjacent side. Hypotenuse and adjacent side of the triangle with respect to A. Now hypotenuse is 17x and the adjacent side is 8x. So therefore sec A is 17 by 8. So the next question given to us is sec theta is 13 by 12. Calculate other trigonometric ratios. So let's take a triangle here. So I have angle theta. What is sec theta? Sec is given by hypotenuse by the adjacent side. So this would be 13x by 12x. So when I divide this, it will be the ratio of sec theta, that would be 13 by 12. So the hypotenuse is 13x. The adjacent side with respect to theta is 12x. And this I have to calculate by Pythagoras theorem. So let me name this triangle ABC, right angled at B. So using Pythagoras theorem, I have AC square is equal to AB square plus BC square. AC is 13x the whole square equal to 12x the whole square plus BC square. Now I'm interested in BC, so I'll shift this to the other side. 13x the whole square minus 12x the whole square equal to BC square. Using A square minus B square, we know A square minus B square is given as A plus B into A minus B. If you observe here, this is A square minus B square, where A is 13x and B is 12x. So BC square would be 13x plus 12x into 13x minus 12x. 13x minus 12x would be x. 13x plus 12x would be 25x. 25x into x would be 25x square. Now this is BC square. I want BC. So BC would be root of 25x square, which is 5x. So here I have BC as 5x. So sin theta, sides with respect to theta, Sine is given by opposite by hypotenuse. Opposite with respect to theta, that would be 5x by 13x, which is 5 by 13. Cos theta is reciprocal of sec theta. Sec is already given to us as 13 by 12. So cos would be 12 by 13. Tan theta is opposite by adjacent with respect to theta. So side opposite to theta is 5x and the adjacent to theta is 12x. So the cancelling out x, the ratio is 5 by 12. So then I will take cot theta, which is just reciprocal of this. So it would be 12 by 5. Cosec theta is reciprocal of sin theta. Sin theta is 5 by 13. Cosec would be 13 by 5. So those are all our trigonometric ratios. Okay, so I'm moving on to the 7th question, because question 6 would require similar triangles, which I haven't covered yet. So once I cover the similar triangles, I'll come back to that question. So here, evaluate 1 plus sine theta into 1 minus sine theta. That is the part A and that is part B. So first we'll deal with part A. It is 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. This is a plus b into a minus b, that is a square minus b square. 1 square would be 1 itself, by 1 minus cos square theta, because here also it's 1 plus cos theta into 1 minus cos theta, which is a plus b into a minus b, which is a square. 1 square would be 1 itself, minus cos square. Now what is given to me? Cot theta is 7 by 8. So I have cot theta is given as 7 by 8. Cot is given as what? Cot theta is given as adjacent by the opposite. So the adjacent, it is given as 7 by 8. So the adjacent would be 7x and the opposite would be 8x. So this is 7x, this is 8x. Now again I have to find this using Pythagoras theorem. So I have AB square plus BC square equal to AC square. So AB is 7x. So 7x the whole square plus 8x the whole square is equal to AC square. 7x is what? 49x square plus 64x square, which is 113. So I have this is 113x square. This is AC square. So just draw a line here. AC square is this. So AC would be root of 113 x square. X square would come out as x. So x root 113. So here this is 113x root of. So now let's write down what is sine theta. Sine theta is opposite by the hypotenuse. Opposite to theta is 8x. 8x by root 113x. Cos theta is adjacent by the hypotenuse, which is 7x by root 113x. This gets cancelled and this gets cancelled. So this is 8 by root 113. This is 7 by root 113. Now over here, I have 1 minus sine squares. So square of this. So 8 root 113 whole square by 1 minus 7 by root 113 whole square. Okay. So this would be 1. This would be, one second. So this would be 1 minus 8 square is 64. Root 113 whole square is 113 by 1 minus 7 square is 49 root 113. Now I'll take the LCM in the numerator. This would become 113 minus 64 by 113. 113 minus 49 by 113. So this would give me 49 by 113 by 64 by 113. So this is 49 by 113. Division is inverse multiplication, 113 by 64. So this gets cancelled and what I have left is 49 by 64. So this would be 49 by 60. So this is 49 by 64. 64. Now I also need to find cot theta the whole square. I already have the value of cot theta. Square of this would be 49 by 64. So cot theta was already given to me as 7 by 8. Now square of this value, that's cot theta the whole square, is equal to 7 square by 8 square, that is 49 by 64. Okay, this is the next question. If 3 cot A is equal to 4, check if 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. So I will first shift this 3 to the other side. So we have cot A is equal to 4 by 3. So taking a right angle triangle here, A is my angle. So these are with respect to this. So cot is what? Cot is adjacent by the opposite. So my adjacent side would be 4x and my opposite side would be 3x. So BC, using Pythagoras theorem, AC square is equal to AB square plus BC square. AB is 4x, so 4x whole square would be 16x square, and BC is 3x whole square would be 9x square. So this would be 25x square. AC would be root of 25x square, which is 5x. So I have 5x over here. So what's the value of tan theta? Oops. Okay, I don't need tan theta because that's anyways the reciprocal of cot, so I don't need for this side, but I do need cos and sine. So what is cos A? So I don't really need to take tan. So cos is adjacent by the hypotenuse with respect to A. So that would be 4x by 5x, 4x by 5x, which would be 4 by 5. And sine A would be opposite by hypotenuse with respect to A. Opposite to A is 3x by 5x, that's 3 by 5. Now let's solve our left side. This is left side, so left hand side is 1 minus tan square A by 1 plus tan square A. Now tan is reciprocal of cot, so it would be 3 by 4. So 1 minus 3 by 4 the whole square by 1 plus 3 by 4 the whole square. So that would be equal to, this would be equal to 1 minus 9 by 16 by 1 plus 9 by 16. Taking the LCM, that's 16 in the numerator and 16 in the denominator. 16 minus 9 by 16, 16 plus 9 by 16. So here I think there's a little screen problem that happened. So over here what I've done is, so by cancelling out, so 16 minus 9 by 16 became 7 by 16, and 16 plus 9 by 16 became 25 by 16. So the cancelling out the denominators, we have 7 by 25. Now in the RHS, that is cos square minus sine square. Cos of A was 4 by 5. Now whole square of that would be 4 by 5 the whole square, minus sine A is 3 by 5. You can refer to the diagram which we have taken down earlier. So 3 by 5 whole square would be 9 by 25. So 4 by 5 whole square is 16 by 25. 3 by 5 whole square is 9 by 25. Since the denominators are same, I can subtract the numerator. 16 minus 9 by 25, which is 7 by 25. Now I can name this as equation 1 and this as equation 2. From equation 1 and 2, we have LHS equal to the RHS, as both of them are equal to 7 by 25. 8.1 ninth question. So it's given in a triangle ABC, right angled at B. So I have a triangle here, right angled at B. So wherever I have 90 degree, that would be B. So I can have here A, B, C. If tan A is 1 by root 3, find the values of this and this. So it's given to me tan A is 1 by root 3. Tan is opposite by adjacent. So opposite would be 1x by adjacent root 3x. So this would be x, 1x is same as x. This would be root 3x. Now using Pythagoras theorem, I need AC square. AC square is BC square plus AB square. That would be x square plus root 3x the whole square, which is x square. Root 3 square is 3. X square is x square, which is 4x square. This is my AC square. So AC is equal to root of 4x square, that is 2x. Okay, so I have the hypotenuse as 2x. Now let's find out the ratios that I need. Let's find out and write it over here. Let me write it here because anyways I have the space. Sine A. Sine is opposite by hypotenuse with respect to A. Okay, opposite by hypotenuse with respect to A. So opposite side with respect to A is x, hypotenuse is 2x. So x by 2x, that is 1 by 2. Then we have cos C. Now the sides are with respect to angle C. Cos is given as adjacent by hypotenuse with respect to C. So with respect to C, the adjacent is BC. That would be x by the hypotenuse, that is 2x. So it's 1 by 2. I need cos A. Cos A is again adjacent and hypotenuse with respect to A. So with respect to A, adjacent is root 3x and hypotenuse is 2x. So it's root 3 by 2. And then I need sine C. So sine C is equal to opposite by hypotenuse with respect to C. With respect to C, the opposite is AB. So that would be root 3x by the hypotenuse, that is 2x. It would be root 3 by 2. So let's substitute. So we have sine A, solving the first one. Sine A is half. Cos C is again half into. So if there's nothing, no sign in between, that means it's the product. Or you might have a dot over here. Plus, now cos A is root 3 by 2. And over here, you have sine C as also root 3 by 2. So into root 3 by 2. Half into half, the numerators get multiplied. It's 1 by 4. 2 into 2 is 4. Plus root 3 into root 3 is 3 by 4. That would be 4 by 4, which is 1. Okay. What I'll do is, again, I'll redraw the diagram because it's kind of cramped over there. So let's, yeah. So again, I will take my triangle here. So this is the question and I've redrawn the diagram here. So cos A. So cos is adjacent by the hypotenuse with respect to A. So adjacent with respect to A is root 3. So this would be root 3x by 2x, that's root 3 by 2. Cos C is adjacent by hypotenuse with respect to C. So that would be x by 2x, which would be half. Sine A. Sine A is opposite by hypotenuse with respect to A. So that would be x by 2x, that's half. And sine C is adjacent by hypotenuse, opposite by hypotenuse with respect to C. So that would be root 3 by 2. Okay. With respect to C, opposite is root 3, hypotenuse is 2. X, of course. Cos A, let's substitute, is root 3 by 2 into sine C, that is half, minus sine A, that is sine A is what? Half into sine C, that is root 3 by 2. So this would be root 3 into 1 is root 3 by 4 minus root 3 by 4. The values are same and the signs are opposite, so they cancel and it becomes 0. So this is the next question. One second. Yeah, I think that's fine. In a triangle PQR, right angled at Q. So I have a triangle PQR where the 90 degree is at Q. So I can have this as PQR. So it's given to us that PR plus QR is 25. PR plus QR is 25. PQ is 5. Okay. Determine the values of sin P, cos P and tan P. Okay. Now guys, do you agree that by Pythagoras theorem, PR square is equal to PQ square plus RQ the whole square? So here I have the value of PQ. I'll shift everything to the other side. So PR square minus RQ square equal to PQ square. Again, this is of the form A square minus B square, which can be written as A plus B into A minus B, okay, equal to PQ square. Now we know the value of PR plus QR, which is 25, so I substitute it over here. PR minus RQ, okay, and PQ we know is 5, so 5 square would also be 25. Now I shift this 25 to the other side, so I have PR minus RQ equal to 25 by 25, which is 1. So I have two things here. PR minus RQ equal to 1 and PR plus RQ equal to 25. I will add these. PR plus PR is what? 2 PR. Minus RQ plus RQ, they will cancel out. 25 plus 1 would be 26. So PR would be 26 by 2, that is 13. So PR is 13 and I need to find RQ. So I have this equation, PR minus RQ equal to 1. So PR is 13 minus RQ, I shift to the other side, it would become plus RQ, and plus 1 I shift here, it becomes minus 1 equal to RQ, or RQ equal to 12. So I have my triangle here now. I found all the values and I need to find sin P. Sin P is opposite by the hypotenuse with respect to P. So opposite to P is 12 by the hypotenuse, that's 13. Then cos P. Cos P is adjacent by the hypotenuse with respect to angle P. The adjacent with respect to angle P is 5. So that would be 5 and the hypotenuse is 13. Tan P. Opposite by adjacent with respect to P. Opposite to P is 12. So this would be 12 by, one second, this would be 12, hold on, 12 by 5. Okay, we'll continue with the rest in the next video.